So today we're going to talk about the 2D triangle congruence section. Okay, it's textbook sections 4.2 and 4.4 if any of you want to try to do some more practice. These are the things we should be able to do by the end of this lesson. Okay, so if we see there's a lot of marks on these triangles, we're trying to figure out all the congruent parts. So if we try to be organized here, because we're always organized, right? Sure. Right, angle A is congruent to angle F. We know that because they're both right angles. Angle B is congruent to angle G. And then we also know angle C is congruent to angle H. Alright, we got all the angles taken care of. Now let's move on to the sides. It looks like side AC, that one has one tick mark, is congruent to FH. Okay, and then side AB, that's congruent to side FG. We have one other thing there. We have the last side, BC, and that one is congruent to HG. So we got all the angles, all the sides, so we can write what's called a congruence statement now. We know that triangle ABC is congruent to triangle FGH. Now, order is extremely important in writing what this thing is called. Again, it's a congruence statement. Okay, notice, look, A was my first letter in my congruence statement, and F was my first letter on this side. A was congruent to F, so I had to write it in that order. Okay, and then we have B. B is congruent to G. Okay, notice again the congruency statement, so I had to put them in the right order. If you wrote triangle A, B, C is congruent to triangle F, H, G, H, G, okay, this would be wrong. Don't do that. Make sure you have the right order here, and we'll try another one. Alright, so we have information. We always read the problem. Okay, E is the midpoint of AC and BD. Okay, let's go back to this. So that means if E is the midpoint of AC, then AE, let's write that down, AE, whoa, AE has to be congruent to EC. Right? If E is also the midpoint of BD, that tells us that BE is congruent to ED. BE congruent to ED. Alright, and it already says in our picture here that AB and CD, AB is congruent to CD. So we have all the sides taken care of. Now we're going to start talking about the angles. Well, immediately I can see, bam, we got a vertical pair of angles there. So angle AEB is congruent to angle CED, okay, because of vertical angles. One thing that I didn't use yet in this picture are these arrows. Of course, you know, that means parallel. So because they're parallel, I can assume that angle A there and angle C are congruent because they would be alternate interior angles. Okay, using the same kind of reasoning there, I could also say that angle B and angle D are also congruent because they would be alternate interior angles. Now notice how I had to use 3 letters for these angles because I can't use E because I don't know which angle you're talking about. Now that we have all 3 sides, all 3 angles, we can sum it up together and make our congruence statement that triangle ABE is congruent to triangle CDE. Man, this seems like a lot of work, doesn't it? Listing out 6 things each time. There's gotta be a shorter way. Maybe we'll find out. Not yet, though. Okay, in the diagram, what's the measure of angle D? Well, we notice right away, vertical angles, they keep coming up. They're not going to disappear. Alright, vertical angles, so this has to be 47. And if that's 47, we can add up those angles. We get 118, subtract it from 180. What's left over? Okay, 62. There we go. Angle A has to be 62 degrees. Over here, this would have to be 62 degrees. And using that same reasoning here, this angle, angle C, we can figure that out. It doesn't ask for it, but why not? That's also 71. Alright, so in the diagram, what's the measure of angle D? Well, the measure of angle D is, measure of angle D is 62 degrees. So at this point, is there enough information to tell us that triangle ABE is congruent to triangle DCE? Well, we have all the angles. So we have all the angles. But we only have one set of sides. So is that enough? Well, right now it's not, but maybe in the future we'll be able to figure it out. Okay, there are 3 postulates or theorems that we can use when using side lengths to prove that triangles are congruent. One of them is the side-side-side congruence postulate. And instead of saying that all the time, we can say SSS or write it SSS. Okay, so here it is in lots of detail. Basically, if all 3 pairs of sides are congruent, then the 2 triangles must be congruent. So if I'm going to write a congruency statement, side AB matched side RS. Okay, side BC matched side ST, and side CA matches side TR. Okay, if we look at the angles, remember order matters. Angle A matches angle R, B matches S, and T matches C. So both of those triangles would be congruent by the side-side-side postulate. Okay, that's one way. Another way would be the side-angle side. See how that A is kind of sandwiched in between the 2 S's? Well, that's how we can think about this one. The angle has to be sandwiched in between the 2 sides. So we have our one side here, okay? And if I mark up the other one, if I can get that other color, there we go, okay? Here's another side. If we have 2 sides that are congruent, 2 pairs of congruent sides, remember we looked at that with the hinge theorem. If their angles are the same, then the triangles are congruent. So in this case, triangle RST is going to be congruent to triangle UVW. Okay, so that, and we don't have to do all that work. Find all the sides and all the angles. This is enough. If we have 2 sides with that angle sandwiched right in between, we know they're congruent. Okay, and the last one to deal with the sides is hypotenuse leg. We only can use hypotenuse if it's a right triangle. That's the only time. It must be a right triangle. So in a right triangle, if a hypotenuse and a leg are congruent, then we can say that the 2 triangles are congruent. So in this picture here, triangle ABC would be congruent, and don't forget to match up your letters, triangle DEF. Alright, so to summarize that, side, 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 are all 3 side lengths the same in both triangles. Side, angle, side, are 2 side lengths and the angle in between them the same. Remember, that comes from the hinge theorem. We already learned that. It's just saying if those 2 sides are the same and the 2 angles between them are the same, then the other side has to be the same. And then the last one we have is hypotenuse leg. So in the 2 right triangles, the hypotenuse and one leg must be the same. Alright, I'll do 1 or 2 examples with you. in this triangle. Is that true? Well, are all three sides the same? Well, this one's 8, so is this. This one's 9, and they both share this one. So yes, these are congruent by the side, side, side postulate. All three sides are the same. Okay, let's take a look here. We have one pair of congruent sides. We have another pair of congruent sides. But do we have any more information? We don't know anything about the angles. We don't know anything else about the other side. So no, we don't know. There's not enough information. Right, let's try another one. Looking at these, are these triangles congruent? Well, is it side, side, side? Do we know about all three sides? No, we don't know. We have no idea what that third side is. Can we use hypotenuse leg here? Of course not, because it's not a right triangle. So the only one left that we have to look at is side angle side. Alright, we have a side the same, we have another side the same, and that angle sandwiched in between the two sides is exactly the same. So yes, the triangles are congruent. Okay, and we have one here. Now this one could get kind of tricky, I guess. We have a side. Secretly, look at that. Whoa. We got another side. And one pair of angles sandwiched in between those sides. So that one, another one. Yes, by side angle side. Alright, so at this point, you should maybe pause the video and try to do these yourself. Okay? And then one last one. So we're at the end of the unit. I just want you to try those and come in with any questions that you have.